Yeah. No, don't make me do Bernie Sanders again. That was horrible.
Just only 1% of your students understand what you're saying.
Feels about right.
And the last one,
Alright.
in 4.488, can I start from the original function that they give me? Because I understood that you wanted to come out with it.
So 88, that's the one that says if f double prime is continuous? That one?
88. Yeah.
So they didn't give you a function, though.
No, I mean, start from what they give me to come up with f double prime of x.
No. Well, you could. Yeah, I see what you mean. Yes. As long as you show that that limit that they have does equal the second derivative, you're fine.
No, because I was confused. F double prime x plus h. I didn't know.
So part of the reason I said that is to get you thinking along the direction that you're thinking right now. So for example, f prime was this here, right?
Yes. Yeah.
Okay, cool. So I could try to take a second derivative of this.
Yeah, then it's going to be f x plus h. F prime x plus h. Yeah.
That's right. That's right. And wherever you have an f prime of x plus h, you can replace it with a limiting definition, a limit structure like that. Right? But if you could think of a way to take one side and make it become the other side, you're golden. You just have to know what f double prime, what the form of it is. So you have a goal to reach, right? So if you took that limit stuff they put down there, and you make it look like what a second derivative is supposed to look like, you're done. You've done what they asked you to. So the short answer is yes. Okay, cool. So we don't do 4.6 for whatever reason. 4.6 does point out some interesting things about. There's a book somewhere that says, I can't remember exactly what the title is, but it's about lies my calculator told me. So the graphing calculator is obviously not perfect. So, for example, some older graphing calculators, when you plugged in their irrational expression, sometimes they have a line going straight up. Because if it went to negative infinity and they're supposed to start over at infinity, the calculator freaks is like, holy shit, I'm up there! Whoop, and it would connect it. Yeah. Right, I always told my students a long time ago, I said, it's trying to draw the asymptote in for you, just so they wouldn't freak out. But it's just the calculator freaking out, right? So there are several functions the calculator is just going to show you wrong because it takes higher resolution than it's capable of, for one thing, or very strange things happen at a certain point and it just guesses at what's going to happen. So that's part of what section 4.6 talks about, which is good. But then a large part of it we don't need. So 4.7, most of my time, I think, hopefully you understand, I just printed these grade sheet summaries out. I know I had somewhere a sheet that I gave to my pre-calculus students, because in pre-calculus, you did stuff like this. I don't know if you remember this. Find the min value of 0.1x squared minus 3x plus 11. Something, right? I don't know if you guys remember the shortcut that you used. Of course, for this function, what's the min value? Where is it going to occur? At the what of this? What would this look like if I graphed it? Parabola facing which direction? So it's going to have a what? A min. So thankfully that's what I asked for, right? It's going to have a min. It just goes forever up. So the sky's the limit. It's going to just keep going forever up, but it's got a min to it, doesn't it? Who remembers the shortcut to find the vertex of a parabola?
Minus
negative b over 2a. Where the hell did that come from?
Second derivative?
No. It could. No, it doesn't. Well, it comes from the first derivative, right? But, because again, I can't remember. I thought I showed you this, but maybe not. If I took this guy's derivative and set it equal to 0, Yeah, I did show you guys this, didn't I?
Yeah.
Then you get that back, and that's when I said, do you guys remember this? And that's why a lot of you look at me like, it's got DNA in it. All right. But in pre-calculus, do you guys remember where this came from? Before you were pre-calculus.
Quadratic.
Quadratic, I love it, quadratic, because what's a quadratic tell you? X-intercepts. I love it. I love it. Even if they're complex, they actually still exist on the lateral axis. And I keep forgetting, I did. I sent that out to you, didn't I? That link to the video series? That you're all like, dude, I gotta do your homework. What do you want me to do? But if anybody watches that, it's just so kick-ass cool. It fills in a lot of gaps. They have some nifty animation. Anyway. So if I know the intercepts for a parabola are like at 1 and 3, where must the vertex be? At 2, and then you just plug a 2 in, and that's what this does. Because what controls these intercepts is this. As far as 0 over 2a. So it's negative b over 2a, give or take something. Negative b over 2a, give or take something. That's why negative b over 2a is always in the middle. Alright. I just want to really quickly remind you that in pre-calc we did extreme value problems. They might have called it optimization problems or max-min problems. And they could only give you parabolas because that's all we can handle. The minute it's not a parabola, forget it. Your teacher hopefully maybe said, calculus will help you do this. And you're like, whatever. Alright, maybe. So the thing I wanted to find was a worksheet on just setting up the problem. Because that, of course, is where most students have all their trouble with word problems is, how do you translate what they tell me into an equation I can attack? Right? That's the big trouble with word problem, isn't it? All this freaking words, just give me the equation so I can attack it. Right? So, for example, who remembers this kind of problem? You got a Farmer Joe. He wants to build a pen next to a river. I know you guys, some of you guys remember this, maybe? Does it sound at all familiar? And he's got, let's see, I don't know, 80 feet of fencing to use, and he wants to know how can he get the max area. Stay with me now. So that's the kind of thing. So this is all I would tell you. He wants to set up a pen. And a friend of mine told me not everybody knows what the hell a pen is, but he wants to set up a little area, a little enclosed area, to put a goat or an orc or whatever world he's in, right? Some kind of creature. Yeah, put a little orc. Little chupacabra orc combo. Chupa orca. Sounds like it's a chupa whale. Don't know, it came out of the freaking ground. Leave my orca on.
I use area of rectangle and...
well, first off, what do you need to do? I have nothing to work with yet. How wide is it? I don't know. Yeah, I love it. How long is it? That's crazy. So I've said this before. This is sort of like the related rates only in one way. Because I know when I say that word, some of us get flashbacks. But and setting up the variables and then getting the equation, right? That's how it's like that. Give yourself variables to define the parts of the problem that you can. And they tell you something. This is exactly how I teach it in pre-calc. And then they ask you something. So if you can actually label them, that's fantastic. Then you want to set up the equation for what they tell you, set up the equation for what they ask you, and see how they can work together. I don't know if you guys remember, but that's what we did with related rates, because that's how it works. You want to substitute more information into this one equation so you can get rid of some variables. Okay, maybe. So, of course, what's the formula for what they tell me? 2x plus y equals 8. And, of course, in my pre-calc, I'd have people, they just go to 2x plus 2y. And I'm like, no, if you drew the picture, you don't have this y over there because the orc doesn't like water. For some reason, they don't like to wash. I think if you watch the movie, you're like, yeah, it looks like that. It's true. They were made from mud, so it makes sense. And then they ask me the area, and so what's the formula for that?
XY.
XY. Cool. And again, we see the same problem we had before. It's too many variables there. Yes, sir.
How are you supposed to know not to use that side?
Oh, the problem would have told you that I was hoping this is a classic problem where you have something sitting against the river. It doesn't, so I don't need to fence that side in because it's not going to go in there, right? Because it doesn't want to. If it does, it'll die. It can't swim. So the problem would tell you this side does not need here. Let me make it better. Let me make it better. You're building a thing against a building that comes with its own wall. Is that okay? Cool. So unless it can phase through matter, it's not going to go there. And then you're like, well, screw it. It's not going to do anything. All right, cool. I like it. Thanks, Adrian. Keep me honest.
So,
It's like, you can learn, man. Push an animal hard enough, you can learn. I don't want to be in here. I'm going to learn how to swim. All right. Can't learn how to push yourself through a wall. So then how can I use what they tell me to help me with what they ask me? I've got too many variables.
so y equals 80 minus 2x.
Yeah, so y equals 80 minus 2x. And then you plug that in. So now my area function is
80x
80x.
minus 2x squared.
Now here's where they would do the negative e over 2a. What are we going to do with it?
Derivative.
Take a derivative. Because if I want to maximize or minimize anything, where I start is I find the critical numbers. Exactly. I love it. Now, something like this, you don't have to do any test because the function is way too easy for that shit. What does function look like if you graphed it? What kind of parabola?
It's a
Down parabola, so I know my answer is going to be a max. So if you just say that, it's down parabola, just go, max, must be. I mean, that's it. That's all the work you got to show me because you understand. Now, if I have a harder function, then you have to apply some kind of test. First or second derivative test, whichever one you want to do. All right? But for this guy, this function is too easy for that. So what is the derivative?
80 minus 4x.
And then of course I set that equal to 0.
X equals 22.
X is 20. Is that cool? So X is 20, so Y is what?
So y is equal 40.
40. I like it. Do you see how that's sort of... I don't know if you guys remember, but if I had a rectangle and I wanted to maximize the area, the answer is always going to square it. It's always going to make it a square. Always. Always. So look what happened. If I took... So if this problem would have been a square, it would have been 20... if this problem would have had this side, that building wasn't there, stay with me. The answer would have been 20, 20, 20, 20. So I took that option away, so now it's 20, 20, 40. All that 20 went on that side. I love that idea. It's still trying to be a square, but it's got no side over here, so it's like, I'll just put it all over there. Yeah. I love that shit. I would, but stuff like that's just kind of neat. It's trying to make it a square, and it can't, so oh well, it does the best it can. All right, maybe. I didn't really put units, so it's okay. Feet. There it is. So feet. All right, so that's an easy example, obviously, of what you're going to face in 4.7. But that's the idea of 4.7. So let's try one that's just really pseudo-code for math. What do I mean by that? I don't know. So we got this here? My order's not going here? Okay. Joe, you really shouldn't keep that work. Shut up. I found it. Find two numbers. Well, you guys should be able to... this is almost... Oh, yeah. Whose sum is 16. This will make it easier. Make it more interesting. If I said find two numbers whose sum is 16 and their product is as big as possible... based on what I just said, what would the answer be? 8 and 8. 8 and 8. I like it. Thank you, Steve. Just like you would have been 20 and 20 to make a... I don't know if you guys are with me at all. A little bit? But I'm not going to ask you that. No, because that's too easy. Find two numbers whose sum is 16 and the sum of their squares is the smallest. just come up. Now this is not horrible. You got two numbers, so what are you going to call
X and Y.
them? No way. Holy shit. All right. So I got X and Y. What do they do? They have to be 16. That's what I'm told. Now what am I asked?
Minimum. So X
Sum of their squares.
X squared plus Y squared.
X squared plus Y squared. Good. What's that equal? I know that's the function I'm working with. So if we want to call it anything, you can call it the sum of squares. We'll call it the S function. But you don't have to call it anything. It's just the expression you're working with, right? This has to be a complete idea so I can use it to help me with this. And what do I do now?
So X equals 16.
I solve for whatever you want. Yeah, so if we solve for X, X equals what?
16 minus Y.
16 minus Y, so then I can use that information in here. Alright, so finish it out. So I don't know if this is throwing anybody off. You don't have to put anything there at all. Right? I'm just saying you can't say it's equal to 0. That's insane. The sum of the squares can't be 0. Just have it sitting there, but sometimes we give it a name like it's the S function, the sum function, right? Or whatever you want to call it. Like the area function A is crazy.
So it's gonna look like a square.
Oh. I don't know if you guys are wasting time before really and all that kind of shit. So here's the function I'm working with. There's the marker I'm not working with.
So it's 8.
So I got x squared, which will be 16 minus y squared plus y squared equals whatever you want to call it. Take a derivative, so I get what?
256.
Not quite directly.
16 minus
Good. Plus equals s prime. And then what do I do with that derivative? Because what do I want to do? I'm trying to minimize this. I'm going to take that derivative and set equals 0. Again, this is a small example of what I mean by if you understand the idea, it drives what you do to the problem. If you don't understand the idea, you can't possibly know what to do with the problem. You can't memorize every type of problem. It's impossible. But I want to find a minimum, so therefore I want to find a critical number.
Is that supposed to be a minus 2 or a plus 2?
Just 2.
So the 2 would come down, times this, times the derivative of the inside.
Negative.
Yeah.
Okay.
Right, good old chain rule, right? So if you're worried you're going to forget chain rule, you can certainly expand this. You can FOIL that out. I wouldn't want to, but you can. And then what happens here, I get...
Minus 32.
Yeah, minus 32, you get 2y, 2y is
3y.
4y.
Yeah, 4y.
Minus 32 equals 0. I'm going to set it equal to 0. So then y is
8.
8.
Can I ask you?
Yes.
So minus b over 2a, can I use it like just by opening the 16 minus y squared?
I'm sorry?
So later in the beginning we wrote that x equals minus b over 2a. So can I open it and then just...
If you boil it out.
Yeah, if you put this all together and make it into a quadratic form, and you're going to identify a and b, the answer is still no, because now we're in calculus class, we're not going to use those kind of shortcuts. I like it. Calculus is actually quicker. Yeah. So y is 8, so therefore x is
8.
Aha, so it still came out to be a square. Huh? I like it. Alright, so not too bad yet. So let me put one on the overhead. Not yet. It's all about drawing the picture, identifying the variables, right? I don't mean Is it X, Y, or C, or W, or S? I mean, what requires variables? Stay with me. So, if you got your book, it's, let's do number 14 looks gross. Let's do that one. Page 332, number 14. There we go. Let's do one. Looks pretty gross. Let's do that. That's important. So let me just try to draw this picture. If you're horrible at drawing, you must come up with some way to show yourself the hell's going on. Nowadays, if you're at home doing the homework, you could just Google box with a square base and open top images, and you'll have computer-generated images. I mean, come on. Back in my day, I had to watch my teacher who couldn't draw or shit. He was worse than me. Well, let me represent, and we're like, oh, don't even try. You know, it's not going to work. Back in my day, after I walked uphill both ways. Through the snow, even when it was summertime. Fire and brimstone sometimes. So lived in hell. I like this example to do next because it's a relatively simple picture. And it should be a formula you know. But the formula for what to tell you is where things get interesting. I want to see if you guys can tease that out.
So it's like a cube.
Well, not it could be, but I don't know. I don't know if it is as tall as it is wide and long. Right? So what do I know for sure about the shape of this thing? Square base. I like it. So the base is square. So the way I draw something like this is like that. So you got a square base. So you know that that's X and that's X, or whatever letter you want to use. And this,
What?
that's crazy. All right, or H or whatever you want to use. I like it. Variables are, we call them dummy variables sometimes, just because they stand in the place of real values, right? Poor little variable's going to rise up someday. Equal rights. Sorry. It's got an open top, and what's that mean for me mathematically?
That needs to be one less face on it.
Yeah, one less space. So they asked me about the volume. Let's start there, because we should be able to write the volume formula, right? They asked me about minimizing the... Oh, I'm sorry. They tell me the volume. There it is. And they asked me to minimize the amount of material used. So the amount of material that I'm going to use is actually going to go into constructing the areas of the surface, the surface area, right? I like it a little bit. So they tell me the volume. What's the volume formula?
X squared y.
Yeah, x squared y. You gotta love that shit. So x squared y equals
32,000.
32,000? Alright, so that's nice. They just tell me straight up. They gotta give me some information to get going. And then they ask me about the surface area. Now, what's the surface area gonna be? So this base is an area of what?
X squared?
X squared. I love it. So there's one side with x squared, because there would have been another side, but it's an open top. We want to be able to throw shit in there, right? So we're not going to put a top on this thing. We don't want to close out. Plus,
4xy.
yeah, the other four sides all have an area of x times y. You guys with me here a little bit. This is why you have to give yourself some kind of visual representation of the problem, or you're not going to be able to tease out what the formula looks like. So work on it. You have to be able to make a rectangular box, a 3D rectangular box. At least be able to do that. What did we just say? 4 of these, 4 xy's. That completes it, right? So now, where do I go from there?
So y equals
3.
Yeah, so now I can say, how can I use what they tell me in what they ask me? I can solve this for, what do you want to solve it for?
Solve for y.
Hell yeah, because I don't want to take a route. Right? I don't want to introduce the square root on my variable, and I know I'm going to have to take derivative. Screw that shit. I mean, if I solve for y, you don't always have that option of picking, by the way. Then I can throw that in here, what they ask me, and what good is that doing?
No, you put it in. You can
Put it in, so then I only have
x.
one variable.
one variable. I love it. And I know how to attack that, because it's calculus 3 that's multivariable. Some of us are like, that's okay, I don't need that. So we're going to stay away from multivariable stuff as much as we can. So now the surface area function is x squared plus 4x times 32,000 over x squared. And how can I simplify that? Some of you guys would just start attacking this. You're crazy.
X.
Please, dear God, one of your x's cancel. So some of you would do product rule here. Don't do that to yourself. This is what I mean. Before you start attacking some of the calculus, just take a second and say, can I do something to simplify the way it looks? Normally, if it looks easier, calculus will work better. One place it's not true is natural logs. Natural logs are thinking, you see, we want to break them up. We want to make it less, break it up, and then it's easier. All right. So try to finish this out. This is where pre-calculus would have to use your calculator. You're all like, I was okay with that. No! They're humans. We want to be able to do this stuff on our own.
Or risk losing the world to the computers.
Yeah! Scheisse. This is the generation that must save us. Okay.
Dun, 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 dun.
Oh, what's that? Let's try to be a 0 there. So what do you guys get for the derivative?
Minus.
Minus 128,000 over x squared.
Coolness. And you want to set that
0.
equal to 0. Yeah, see, this should be our bread and butter. You would add that, multiply x squared up, divide by 2, so you end up with x cubed
64,000.
equals 64,000. They gave us a really, really nice number there. Cube root is 64,000. Not 8. 4. Is that what you said? Yeah. Not quite 8. Square root of 64 is 8. Yeah. So x equals 1,000. There are 2 other answers to this, but they are both complex. I think it was in here that I did this weird shit here. That there's one real answer, and the other two answers are equally distanced away from it, so they must be somehow imaginary. So I don't want to. I can't make an imaginary side-length box.
What if it would say maximum instead of minimum? Does that change anything?
I really want this to make sense. That would be impossible. I mean, what does it ask us to do here? Minimize the amount of material used. So, see, you could make something with an infinite surface area and a volume of 0, for example. So when you ask me to maximize it, there's no answer. So very often, the question they're asking is telling you what the function should look like, right? Does that make sense?
Yeah.
So the question they ask you very often is the only question they could ask you, because there is none in the other shit. But sometimes there could be. Most of the time, that's the only option. So what's y? Yeah, 4,000. I'm sorry, not 4,000. 40. Don't let me get away with that. Yeah, that's 40. And so when you square that, what's up? Yeah, this will be 1,600. So what will you get there? You'll get 20. Yeah. You do it, Jeff. So 20 and 40. Who's the what's? Did it tell me? Centimeters. Sorry.